You can assess it by sight.
Say again?
You can assess it by looking at it.
But that won't be accurate.
Yes, otherwise you have to maybe not measure it, but you might have to put it through like a sieve or something.
Exactly. That is the
Yeah.
solution. That is the solution. So you create a sieve of 2 inches dia, and with some machine or some tool, you throw all these stones over the sieve, and all the stones which pass through that sieve, they would be smaller ones, and the bigger ones will be retained on the other side.
Yeah.
Got it? So without going into a quantitative analysis, I have qualitatively and correctly segregated the 2 categories of stones. This is very effective. This is very good. Although it is not accurate, but still it is quite accurate. No stone bigger than 2 inches have been retained here. You agree with me? So we need not waste a lot of time in calculations. We just do this exercise, which could be taking a very short time, and I have a list of qualitative risks. All the smaller risks would be put into a separate box. Now, let me apply 80-20 rule here. The Pareto law. Do you know about that?
No.
Pareto law, Pareto says that if you take an opinion, or for that matter, let me say, give you another example. If you have problems in a system and you categorize those problems, say there are 100 problems, the problems which have got the highest number of frequency, you order them according to their number of frequency, right? The Pareto, have you seen a histogram?
Yeah.
Histogram is something like, for example, the first category is this much, second category is this much, third category is this much, fourth category is like this, and fifth category is like this. You see, this is how a histogram looks like, right? But if I can bring the highest line first, so that could be like, my new histogram would be the highest line first, the second highest line second, and third highest line third, and fourth highest line like this, and the fifth highest line like this. You see, I have ordered them in order of priority. The problem which is occurring the most is the first, then the second one, third one, fourth one, and fifth one. I have ordered them. When we order them, it is called Pareto diagram. This is a normal histogram. The same histogram could be translated into a Pareto diagram. Pareto says that 20% of the top ranking problems are 80% heavier than all others. Meaning, if I can fix these 2 problems, the first 2 problems, probably I would be able to, there are so many issues in these, there are so many instances in these 2 categories, so many, these 2 defects are posed by so many people that if I can fix these two defects, 80% of my customers will be satisfied. Rest, number of defects, whatever they are, rest categories of defect, they collectively will hold the weightage of only 20%. So, in a way, I could say that the first two bars stand for the stones which were bigger than 2 inches. They are less in number, but they are the heaviest of the whole lot. They may be carrying 80% of total weight. Whereas the remaining risks, which are all very small, they are all smaller than 2 inches. If I weigh them all, maybe they are in thousands, but when I weigh them all, they cater for only 20% of the total load of stones. This is the 80-20 rule, or we call it the Pareto law.
How do you spell that?
Paerto.
Okay.
Paerto law diagram. And the other name for it is, no, sorry, PAREP. And the other name is 80-20 rule. Got it?
Yes.
Okay. So once we have done that, once we have done the qualitative analysis, you see, say there were 100 different things, 100 different risks identified, and we have, say, 10 categories. Out of the 100, 80 of the 20 risks, which are the heavier ones, and they have cumulative value if you talk about money, the cumulative value to treat them is 80% of the amount. So 20% of the risks, of the biggest risks, will require 80% of the money, and the remaining 80% of the categories will require just 20% of the funding. Does it make sense? Okay, good. Once we have done that, you see, most of the problem of risk analysis is over, because many risks could be responded immediately after the qualitative analysis has been done. In some simple projects, we don't ever need to go for quantitative analysis. Or I would say smaller projects, we don't do quantitative analysis. Quantitative analysis is optional. Only in case of complex projects, we go for quantitative analysis. But the purpose of quantitative analysis is not to analyze individual risks. But the primary purpose of quantitative analysis is that we want to find the overall risk to the project. The cumulative risk to the project. How much risky is this project? So, if I add up the amounts of all the risks, that would give me the total quantitative value of risk to this project. But remember, I did tell you that a risk is equal to probability multiplied by amount at stake. Remember that. If there is a risk that there will be a damage of $100,000, you don't put $100,000 in your calculations. You see how much is the percentage, how much is the probability. If the probability is 10% multiplied by 100,000, you will consider 10,000 as the risk amount for that risk. So 10,000, and naturally you add up all the 100 risks, whatever is the total is your quantitative analysis, is your overall risk of the how risky your project is. Also remember that because we have been talking about risks, and we are by default considering the risks are negative, which is wrong. There are positive risks also. So the positive risks will be having a positive figure, and negative risks should be shown with a minus. So when we add them up, if your answer is positive, then that means your project is overall positively risky. If the answer is negative, then your project is negatively risky. I mean, it has more threats, right? So if the figure is negative, this is bad for the project. If the figure is positive, it is good for the project. So quantitative analysis is for that purpose. Okay, I suppose we can have a break now, and then I can start describing to you the this chart and how the probability and impacts are calculated and all that. So do you want to have a break?
So,
So let
Okay.
us have a break for 20 minutes, and then we will start again. Thank you
Okay.
and take care.
See you soon.
Thank you.